Good afternoon, everyone. This is Emmanuel Guilherme Jr. with your presentation this afternoon, governing the data in your AI that you doesn't know it's leaking. So it's a practical OWASP framework to help you out. Who am I? I am one of the founding members of the OWASP Top 10 for large language models. I've been with the project since its first iteration when it started back into 2023. And I lead the data security initiative among the project. And on my day job, I'm a senior global IT auditor for an auto manufacturing company. I'm also the author for the data security risks and mitigations, along with Scott Clinton and Rock Lambros. And I created the GenAI Security Crosswalk. And I'm also a contributor in the Canada Mirror Committee for AI. I also had the privilege to work as a technical reviewer for the book called AI Native LLM Security, published by PACT last December. And I'm also an advisor for GenAI security programs that will be able to stand audit. Let's jump right in, and I hope today you get out of the session with some valuable information that you can be applying to your organization at free of cost, no sales pitch here, and just high value content published by the group, which I'm honored to lead. This is the consensus of multiple experts in the field that put on quite a lot of hours to make sure with these frameworks can be applied and help guide you and your organization into the right track to secure your GenAI programs. So, first off, we're gonna talk about start somewhere that may sound a little bit abstract for the moment. Stay with me. Because this is the entire reason this talk exists in a traditional system, instructions are and data are separated, but no more, right? The application code lives in one place, the user input and processes lives in another. We build 30 years of security architecture on top of that. The separation, DLP, IDS, role-based access security, audited logging, and the whole stack. And they all assume there's a boundary between the program and the bytes, and the program is reasoning over. The LLM context window does not have that boundary. The system prompts, user inputs, retrieved documents, tool outputs, conversation history, they all flow into one flat namespace. And there's no internal access control. There's no tag inside the window that says this is available for reasoning, but do not direct output. There's no perimeter between the prompt and the data. The prompt is reasoning over. There's no reliable boundary between the user, the document, and the agent that is acting on both. So new challenges will come from this new substrate. So we can why your controls fall short. So now when I say you can't bolt onto this stack you already have, so there's no way you will be able to fix the old way of doing things. I want to be very specific about why, because every CISO in this room has a stack and a budget that has already been spent. DLP and CASB scan data in Notion across known channels. They miss retrieval that happens inside the model's own context. IDS and IDR pattern match traffic and process behavior, but embedding similarly, it's not a signature. So the most interesting GenAI leaks are invisible to that layer. CSPM and the original generation of DSPM watch storage configuration at data rest. Vector stores and embeddings live below their asset graph. Um, Identity access management, role-based access control, authorize humans against resources, but agents do not carry those employee badges. So the tools that they call execute beyond the user scope. And the CM and audit logs, what was queried, not what was reasoned over. So the CM will have records of what was queried and not the reason behind that. So that's a new threat surface that we're dealing with. And the leak appears in the logs as an authorized response. So I want to present to you today three OWASP resources and that can help you create one program grade toolkit to help your organization to address those issues. So the first one we have at our website genai.owasp.org, the publication white paper, GenAI Data Security Risk and Mitigations, which we will be looking into that today. 21 risks that were identified by the experts, and we also proposed mitigation in tiering layers. Tier 1, crawl, walk, and run. So foundational, hardening, and advanced, because we understand not all there's no program that fits everyone and all industries, and maturity levels are different among organizations. So we need a different approach on how people can use that and start seeing results right away. So that was one of the important parts that we identified there. The GenAI Security Crosswalk. So the question then became like, okay, how do we map all of the risks and vulnerabilities we found on the top 10, agentic top 10, and data security GenAI risks to the most used frameworks such as NIST, MITRE-ALAS, ISO 42001, AUAI Act, which is just around the corner, and also GDPR. So we also have an interactive tool there. Just bear with me. You see my GitHub in this slide. However, I will be migrating this to the OWASP organization as we want to share and give it back to the community. So it's a very interactive tool where you see the risks and where they land, and just to help you understand where your gaps are. And also, I want to point to Sandy Dumb's and Rock's threat defense compass tool. It's a very important profile-based threat modeling and external adversary tool that has many layers to help you understand where the risks are and to define the best strategies and how you're gonna remediate or mitigate or transfer those risks. So okay, so let's see or risks or 21 risks and categories. So this is the surface area. 21 risks color coded into 7 categories: data leakage, identity and access, government and life cycle, data poisoning, compliance and regulatory, infrastructure, and adversarial attacks. I'm not going to read this for you. The point of this slide is the shape to anchor your mind that data security in Gen AI, it's not one problem. It's seven problem families that 21 specific failure modes. And you need a framework that names them specifically, then you can prioritize. Each risk has three mitigation tiers as I presented. So foundational, hardening, advanced. Foundational means you can deploy in one sprint, no architecture changes. Hardening means you need new tooling, cross-team coordination as well. And advanced is for more mature programs where you're gonna start using differential privacy, machine learning, and formal verification channels. Take a screenshot of this slide, take back to your team. You're about to look into five of these clusters. And but the screenshot, it's your map. So let's begin with the cluster one. But before that, we have a field pattern to make a comment. So just before I start the clusters, I want to take back and show one example of the leak that nobody saw coming. So this is an example for a multi-tenant RAG assistance. Three boundary failures with zero alerts. So the setup: a SaaS provider stand up a customer support RAG assistant, multi-tenant, each tenant documented are embedded into a shared vector index. Tenant ID metadata field is attached to every chunk where filter is supposed to enforce isolation and retrieval, but we see in the vector store posture that that's not always the case. And then the Act 2, the trigger. Tenant A support agent uploads an internal document, names, account numbers, unredacted spreadsheet. It is embedded, indexed, tagged. Weeks later, tenant B end user asks an ambiguous question. The retrieval pipeline pulls candidates by similarity, then applies the tenant filter post hoc. But the LLM has already been handed a pre-filter preview snippet for context grounding. So then all of that data, it's at their disposal. In the final act, the act three, the detection chain misses. DLP didn't see it. The data never crossed the network boundary. CM didn't see it. Every query was authorized. CSPM didn't see it. Infrastructure was healthy. The leak surfaced via a customer support ticket 43 days after the index was built. The provider learned about it from the customer. So there's also telemetry leakage there that is possible. So let's look into it. Um, Cluster one, data doesn't know it's leaking. So four risks here: sensitive data leakage itself, multimodal capture and cross-channel leakage, overboard context windows and prompt oversharing, and no compliance with regulatory regimes. GDPR, sectoral, residency, the UAI Act. Most leaks in this cluster are not exfiltration in the traditional sense. They are oversharing the model, never knew it was sensitive. A paste document, a retrieved chunk, a screenshot that goes to a multimodal endpoint and lands in the model provider logs because nobody classified the screenshot. The CISO question I want you to take from this cluster is: where is your DLP integrated with prompt and response pipelines? Not your network DLP, not your endpoint DLP, the pipeline DLP, the one that classifies the prompt before they go to the model and outputs before they come back. If the answer is we don't have one, That's the first thing on the roadmap when you get back to the office. So, and on the legal side, for every use case, you need to know which regimes apply to the data flowing through it, and you need to have that mapped against where your model provider actually run their interference. So let's go now to cluster number two, which is identity, access, and agent boundaries. So, cluster two, agents do not carry employee badges. Three risks: agent identity and credential exposure. Two, plugging data, exchange risks, and endpoint or browser assistant overreach. Here's the question I think most security programs are not asking yet. When an agent acts on behalf of a user, does the user identity actually flow downstream? Or does the agent assume its own role with a broader scope? Not everyone has an understanding about that. And in most implementations, the second. The agent is a service principal. It holds a standing token. The token is scoped at design time, not at request time. And when the agent calls a tool, a plugin, a function, and an external API, the data going across that boundary is not classified, logged at the same fidelity that a human transaction has. Treat agents as a new identity class, not service accounts, not human users. And a third class, which is its own credential lifecycle, its own scope rules, its own per call audit trail, and for browser residency assistance, the Copilot styles ones that are really reading the page you're on. So everyone using Copilot, the page that they read, they apply a deny by default policy on internal SaaS, finance tools, and your source code web UI. Quick cross reference here. If your organization is shipping agentic systems, specifically, look at the CSA Cloud Security Alliance Maestro framework, layer 3 agent frameworks, and layer 7 that covers the agent ecosystem. The data security risks will give you data flow viewpoint, and Maestro will give you the layered agent view. So use both together. Let's go to the next cluster now, which is cluster number three, data integrity and poisoning. So, what your model believes it can be edited. Three risks here: data model, artifact poisoning, data integrity and validation failures in retrieval, and disinformation attacks via poisoning of public sources the model trusts. I wanted to internalize this. Integrity is a GenAI system, is a runtime property, not a one-time validation. Your training data, your fine tuning corpora, your live retrieval indices, they're all writable surfaces. And Poison believe that the model is not patched by deploying new code. You either retrain or you red team and detect, or you live with it. The question I ask your team is, for every corpus we train on, fine tune on, or retrieve from, who has the right access? And is it every commit signed? Most organizations cannot answer that question for their RAG indices, and that's the first thing to fix. Drift directional retrieval indices is the second thing. Content drifting, distribution drift, label drift, same playbook as a classic machine learning observability, just applied to your live retrieval surface, which takes us to the fourth cluster now, governance, lifecycle, and shadow AI. Um, and this one is where most of the painful audits have their findings. And as an auditor, I can assure you that you cannot govern while you cannot have inventory. Five risks: shadow AI and unsanctioned data flows, data governance and classification, synthetic data and anonymization pitfalls, telemetry and monitoring leakage, and human in the loop or labor of overexposure. So those are the risks the team have identified for this cluster. Most AI governance failures are not policy failures. The policies exist. They are inventory failures, followed by life cycle failures. You discover 10 use cases, you write a policy, you put a review board in place, and then somebody on the data science team builds use case 11 through 18 using their personal Anthropic account and a free Hugging Face space, and for the Copilot embedded in Microsoft 365 that nobody categorized as a Gen AI system. You don't know about any of them. So developers tend to try to make things work, not always aligned what the policies and legal has established for acceptable software use in the organization. So inventory first, classify second, then policy. Skip step one, and the rest is theater. The underappreciated risks on this slide is uh, 14, excessive telemetry and monitoring leakage. Your observability stack, Lensmeet, Helicon, your provider dashboard, your homegrown logging, it's now ingesting raw prompts, which means your CM or whatever sits downstream of those logs may have just become your most sensitive data store. And nobody sizes the control for it, which takes us to cluster five, infrastructure, inference, and IP. So AI infrastructure is data infrastructure. Six risks here. Cross contexts and multi-user conversation bleed, unsafe natural language data gateways, vector store, platform data security, data availability and resilience failures, inference and data reconstruction, and model and IP replication. Um, the framing I want you to take from this cluster is the track vector store and the model itself as a crowd view data assets because they are embedding scary signal beyond the source text. The model fine-tune your data, costing real money to train. Is it intellectual property? They both deserve the same encryption, key management, access review, and disaster recovery posture as your top tier production databases. In most organizations today, they don't have it. And for every natural language gateway in your team builds, no SQL, no NL to API, NL to shell, the question is what the allow list action set is and how that allow list is enforced before execution, not after, not by the model, before. Because the model will find a way to reason itself into action you didn't intend, giving enough adversarial pressure. So there's new ways in which this data can be exfiltrated from an infrastructure standpoint. And then that takes us to an overall view of the data security risks we have identified. And now it takes us to what we will try to build to cross-reference across industry frameworks that will help your organization stay secure. And which we build, that's why we built the crosswalk. So in the slide here, I'm going to take a position. Most CISOs in this presentation this afternoon are not short of frameworks. You are short of order. Which one to pick first? Which one to ground first? Which one matters when the audit committee asks? So here is the order I would give them. Where to anchor governance. So ISO 42001 is certifiable, it's audit friendly, it plugs into your existing 27001 ISMS, and you will reuse roughly 80% of your existing controls. And you give the board a recognized artifact. Where to ground risk. NIST AI framework. So not certified, but govern, map, measure, manage. Shape is the cleanest mental model on the market. Use it as your internal risk taxonomy. Map every DSGAI risk to one of the four functions. And where to ground threats. MITRE Atlas plus the data security GenAI risks. Atlas give you adversary technique level detail, and the data risks will give you a data layer view Atlas doesn't. Use both for threat modeling, Atlas for attacker behavior, and data security risks for data flow exposure. And where to anchor legal. So the EU AI Act and GDPR, plus any sectoral rules that fall into your jurisdiction. So tiering them will have you uh, a good layering to approach this from a legal standpoint. GDPR for the data science foundation, sector rules, finance, healthcare, telecom, layer on top of it. And where to operationalize in AppSec. So the OWASP top 10 plus the DSJI. So you have 10 risks which are in the process of being revamped and updated, which I am honored to be co-leading one of the entries with Ken Huang. So we are responsible for LLM 02, which is sensitive information disclosure, which I firmly believe will stay in one of the top tens. And how you ship agents. So use the Cloud Security Alliance Maestro framework by Ken Huang. So this is the best framework you can have. 7 layers for designing autonomous tool using patterns. Pair with the OWASP Agentic Top 10. Amazing work for the team led by John Sotiporolos and Rom. um, and the data security won't cover all because we understand not in repetition but to use as one corpora. So take a starting point. This is not a gospel. This is a starting point. Your context will shift the order, and as you walk into a board meeting next month and someone asks which framework do we use, that's the answer I would give. So let's take now the AI data security posture management for GenAI applications. So quick model, 13 capability areas defined by the DSGA guide. Um, The ones in bronze you see on the screen are it's where I would start. GenAI data asset, discovery inventory, data classification, labeling, and policy branding, prompt, RAG, and output DLP controls, vector stores, and embedding security posture. And I would add observability, telemetry, and log retention posture. Um, they are this is your 90-day floor. So you can use them uh, for discovery, classification, pipeline, DLP, vector posture. Uh, the other eight capabilities you see flow mapping, access governance, integrity, third party governance, life cycle training, resilience, shadow AI face in over following 9 to 12 months, I would say. Don't try all 13 at once. It's just it becomes very overwhelming. You end up with a lot of policy and not much delivery. So that's our advice here. And the three disciplines: posture, life cycle, and governance. Um, so Defensible AI program rests on these three disciplines. The first one continuous visibility into where the data lives, who can touch, who can moves. The board question is, show me the inventory, right? So that's a very important point. You cannot protect what you don't know exists. The second one, data minimization, retention, deletion, less data in the prompt, tighter retention on conversations, embeddings, and telemetry, privacy enhancing, fine tuning where the data is unavoidable. And then the board will ask, when it's gone. So how we are controlling the data life cycle and minimizing to need to know basis and actually applying the zero trust principle and the least privilege principle within that. And the governance. So is it do you have a RACI that have the use case approval, a proper risk register that maps to NIST, pre-deployment review gate, and a quarterly board reporting. The board question is, who signed off into those? So this is a very easy to follow three disciplines to apply to your organization when it comes to securing data and understanding the data your AI is leaking. So what good looks like in 12 months. So outcomes, not vibes. Here, seven measurable markers I look when I assess an AI security program. If your program produce these seven artifacts, you have something regulator, a board committee, and an external auditor can all read. One, inventory completeness above 95%. Two, a pre-deployment gate that every new use case passes through. And three, pipeline DLP coverage from your top three sensitive use cases. Four, vector stores inside your crowd view posture. Five, agent identity boundaries documented per use case with per call audit trails. And six, quarterly threat modeling per use case using Compass or Maestro. And seven, but not the least important one, board gate quarterly reporting. So that's the floor, not a stretch goal, not end result, live program that it needs to be constantly reviewed, revised, and refined. So three things to do. Um, what we suggest is by Friday, you run the 20 question assessment on your top three GenAI use cases, applying so you can access that within my GitHub. which is the link is there. So we've got tool free for you to use. So just score, download into your organization, fork the repo for you. And it will give you overview of the data security that you have within your organization. And within 30 days, I think you should complete uh, first pass through Compass workbook, one production use case, and just try to map out and identify the threat scoring, defenses, mitigations, and really establish the roadmap you have for your organizations. As I said, this needs to be reviewed periodically as changes apply to your organizations, new tools are implemented, and within 90 days, pick five that we showed on the AI data security posture management capabilities and put them on a roadmap. Create a discovery classification, prompt RAG output DLP, vector posture, telemetry posture. The 90-day floor, it's a great window for your defensible program. And I hope you've learned something this afternoon. And our responsibility leading the data security initiative, as I always say to the team, it's okay. How can we be different? We can voice what the industry actually needs. How this is real world application and how it can be scalable within the organizations. Uh, Everything changes so fast in this new threat landscape, but this is our effort to try to address those. Thank you very much for your time and for watching. So here are some of the links. You can also follow your work, and please send your teams to participate with us. This is a collective construct which we do. Or Slack, or OWASP Slack channel is Team GenAI Data Security Initiative. Please join us. We are in the process of building applicable white paper, which takes what we presented this afternoon in a more hands-on, which will be the data security best practices version 2. And now I understand some of you may need to drop. So thank you again. And I'll stick around for some questions. And yeah, please shoot us our way. Thank you.